Take a look at this station. Around 2030, NASA plans to use a dedicated SpaceX vehicle to deliberately push the International Space Station out of orbit, sending it to burn up in Earth's atmosphere. When the remains of this $100 billion laboratory plunge into the Pacific Ocean, low Earth orbit will not be left empty. To understand the transition, we have to look back at the mid-20th century, when outer space was the exclusive domain of sovereign states. National agencies like NASA directly financed and operated every facet of orbital flight. During this period, NASA relied on cost-plus contracting. It's like hiring a crew to renovate your kitchen and signing an agreement that guarantees them a profit regardless of how many times they go over budget. This procurement model removed the incentive for cost control, it slowed the pace of development, and kept the price of space travel high enough to restrict access to high-margin telecommunications and basic science. This chart tracks NASA's budget as a percentage of U.S. gross domestic product. Following the peak of the Apollo program, funding underwent a dramatic contraction. It declined to less than 0.2% by the late 70s, establishing a baseline where it has remained for decades. The shift to commercial space operations was a continuous evolution rather than a sudden break. It was supported by the 1990s creation of commercial licensing regimes and the allocation of spectrum for satellite networks. The modern boom is the result of a forced structural change in how the government pays its bills. The real turning point arrived in 2006. With the Space Shuttle nearing retirement, NASA launched the Commercial Orbital Transportation Services Program to supply the International Space Station. NASA abandoned cost-plus contracts in favor of milestone-based Space Act agreements. Under this framework, the government only pays if a company hits specific performance targets. If the mission fails, the private partner assumes the financial risk. This financial pressure forced companies to move away from disposable hardware. To remain profitable under fixed-price contracts, they had to solve the engineering challenge of rapid reusability. The SpaceX Falcon 9 became the primary evidence that this economic shift worked. By standardizing the landing and reuse of boosters, private companies lowered the cost of delivering mass to orbit, which had been the primary constraint of space settlement. Because launch costs dropped, the government won't replace the ISS with another single, state-owned laboratory. Instead, the industry is moving toward commercial LEO destinations. These are modular, multi-use facilities like Orbital Reef, which are designed as business parks for research and manufacturing. These new stations use innovative construction methods, such as inflatable modules made of high-strength polymer weaves. These structures pack compactly inside a standard 7-meter rocket fairing and expand to their full volume in orbit. Engaged. These platforms will cater to private pharmaceutical research and high-value manufacturing, while NASA pays to use them as an anchor customer. NASA is moving from its historical role as an owner-operator to being a tenant in a competitive commercial market. Operating these commercial stations provides the data needed to develop the closed-loop life supply systems required for permanent off-world residency. Elon Musk's colonization architecture centers on the surface of Mars. His strategy is built on a lifeboat philosophy intended to protect humanity from planet-scale extinctions. Mars is the target because of its resource profile. It has a day-night cycle, an atmosphere containing carbon dioxide, and extensive reserves of subsurface water ice. Jeff Bezos rejects planetary surfaces, arguing Mars is too distant. His vision focuses on constructing giant, rotating orbital habitats in cislunar space called O'Neill cylinders. These habitats would be built using materials mined from the moon. By using solar-powered electrolysis on lunar water ice, Blue Origin plans to synthesize fuel directly at the moon to support this infrastructure. The habitats would rotate to generate artificial gravity, preventing the physiological damage caused by weightlessness. The economic groundwork for this expansion was established through a specific set of administrative changes to government paperwork. Space is no longer just a place for flags. It is a developing market. For clear, research-based explanations of complex future technologies, subscribe to Refreshing Tech.